Hi guys, welcome back. So we have an O-level past paper question of the year 2020. The session was May-June. This is question number 7. We'll discuss exponential equations, graphs, point of intersection, quadratic functions, maximum point and tangent. Let's start. So the first part of the question says the table shows some values for y equal to 4 to the power of x. Then they've given you a table with multiple values of y and of x. They say in the first part to complete the table. Now for the first value of x, which is 0, if you plug in 0 as the power of 4, any number to the power of 0 is 1. So you get 1 in this case. Then they say 4 to the power of 0.5 or 4 to the power of half, which means 4 square rooted. You get 2 in this place. Okay, let's move on. Now they've asked you to draw the graph of y equal to 4 to the power of x for this domain 0 to 3. So we have this table. This table will help us to plot the coordinates first, 0 and 1. The first coordinate is going to be plotted right here. The next one is 0.5 and 2. That means it is going to be between 1 and this 0.5 and 2. Okay, so I believe it is going to be here. The next coordinate is 1 and 4. So this one is going to be there. The next one is 1.5 and 8. Now 1.5, sorry, 2, 3, 4, 5 is going to be on this line, 1.5 and 8, 2 places below 10, it is going to be right there. Okay, then 2 and 16, 2 and 16. So 16, this is the line for 2, this is the line for 2, and this which then is 11, 12, 13, 14, 15, 16. It is going to be right there. The next point is 2.5 and 32. That is higher up. 1, 2, 3, 4, 5. So it is going to be on this line. 2.5. Okay, and going to be at 32 right there. Okay, ignore this point because it is not necessary. I was just trying to make sure I was on the right line. Okay, 3 and 64. The last point is going to be at 3 and 1, 2, 3, 4 right over there. Now we draw a curve. Now in order to draw this curve, I'll use a blue line and flip my iPad. So I have a freehand drawing. If I start from this point, go all the way up till this, connecting all the points right there. Okay, this shows a line of, this should have been a line of best fit. Maybe it is, maybe it's not, but aim to get a line of best fit. Okay, this is done, this part is done. Let's move on. This graph looks like this. Okay, by drawing a tangent, estimate the gradient of the curve when x is 2. They've asked you to plot a tangent at this point right here. So we'll do that. We'll take out the scale and we will try to draw a tangent that only touches this point. Let's do that. Okay, one second. Oh my god, looks better. So I draw a tangent that goes through this point and cuts the graph at x equals to 2. I made sure that I plot one of the points over here and the other one over here so that it's easier for me to read. So the first point has coordinates over here. Let me write down the coordinates. 1, 2, 3. So they are 1.3 and 0. Okay, and the other coordinates are 3 and 41. Okay, let's find the value of the gradient. So the gradient is found by subtracting y1 from y2 and dividing that by x2 minus x1. So y2 in this case is 41, y1 is 0, 41 minus 0 over, you have x2 as 3 and x1 as 1.3. So 3 minus 1.3. Okay, let's plug this into the calculator. Let's see what we get. 41 over 3 minus 1.3. The gradient that we get is 24. 24.1. Okay, I hope this is visible and this may be correct. 24.1, that is your gradient. I have written it over there. Let's move on. The next part says the solutions of the equation 3 times 4 to the power of x plus ax plus b equals 0 can be found from the points of intersection of y equals 4 to the power of x and y equals 20x minus 12. Find the value of a and the value of b. First, we need to equate these two equations, this one and this one. So when we do that, we write these equations right next to each other. We need more space to solve this question, so I'm going to start from the left. So y equals to 4 to the power of x, that means this equals 20x minus 12. We're trying to equate this so that we can equate both of their value, like we can find the uniform equation from these two equations and then try to equate that with this equation to find the value of a and of b. So I bring everything to the left side. I get 4 to the power x minus 20x plus 12. Okay, now this equation should be equal to this equation, 3 to the power of 4 x plus ax plus b. Now, in order to get this, the first part, that means this, needs to be multiplied by 3. If this is being multiplied by 3, that means the entire equation is being multiplied by 3. So I write 3 and I multiply the entire equation that I have on the left with 3. So when I do that, in fact, I'll just straight up multiply this equation by 3 in its place so that I can save some space. I'll multiply this by 3. So I get 3 times 4 to the power of x, which is equal to this on the other side, minus 60x plus 36 equals 3 to the power of 3 times 4 to the power of x plus ax plus b. Okay, now ax is equal to negative 60x. That means a is equal to negative 60. So I write a as negative 60 and then b is equal to 36. So these are the two values. Because you're trying to find these values by looking at this part of this equation and this part of this equation. That is why I equated both of them. I hope this made sense. Let's move on. By drawing the line y equals 20x minus 12 on the grid opposite, find all the solutions of this equation. Okay, that means we need to draw a straight line for this function. Let's do that. First, we need a table. We need to draw a table so that I can put down all the values of x and of y. So I write x here and y here. Then I choose 3 values of x. Any 3 values would do, but I try to choose positive values because the graph that we have here has all the positive values of x and all the positive values of y. Let's do that. So I choose 1, 2 and 3. When I plug 1 into this equation right here, I get 20 minus 12, which is 8. When I plug 2 into this equation, I get 20 times 2, which is 40. 40 minus 12 is 28. So I get 28. Then I plug in 3. I get 3 times 20, which is 60. 60 minus 12 is 48. Yep. So I get 48. Now let's plot these points on the graph above. So when x is 1, y is 8. So I get a point there. Let's do it in yellow so that it's visible. Let's do it in yellow. So I get a point right over there. I hope this is visible. The next point is 2 and 28. So when I have 2, the value that I have for y is 28. That means 2 places below this, so right there. Okay, when I have 3 as x, the value of y is 48. So at the end, I would need to draw a value that is 48 right over there. Now I take out my scale and I stretch a straight line from these points. Wait 1 second. Oh, that is perfect. So in order to connect these these dots, I draw a straight line. I hope this line is visible. I made sure to cross this line at both the ends, but I don't think we will need that. The question says, find all the solutions of this equation. That means you only need the values of x. So the solution for the first part is right here. What is the value of x going to be right there? So it is going to be 9 and then 0.75. So x over here is 0.75. Okay. Now this part right here, I hope this is visible. X over here would be, one second, the line stretches to this point. So 2.8, 2.7, 2.6. So x is 2.6 over here. So I can write the values of x as, one second, I'll write them in red. X is equal to 0.75 and 2.6. Those are the two solutions of this equation. Let's move on. The last part. The last part is worth 3 marks. Okay. Here is a sketch of the graph of a quadratic function. Okay. They've given us a quadratic function. They haven't given us an equation, but they've given us two roots. They've given us the y-intercept and they've given us these points. The curve has a maximum point P, Q. The value of the maximum point is P and the value of the maximum point of y is Q. Find the value of P and the value of Q. Now, if you look at this equation, or if you look at this curve, P and Q is supposed to be exactly in the middle of this graph. That means if I draw a line that stretches, a dotted line that stretches from the top and goes like this, the value of P should be between -2 and +4, exactly between them. So what I do is I add -2 and +4 and I divide them by 2 to get the value of P, because since it's exactly in the middle, I divide it by 2. I divide their sum by 2 to get the value of P. P comes out to be 2 divided by 2, which is 1. Simple. So we have the value of P. P is 1. Now, this graph is of the quadratic equation. How do we find the quadratic equation? The quadratic equation is found by first looking at the roots of this graph, which are -2 and +4. So we use these roots to find the quadratic equation. So this is what we do. So the first root is 2 plus x. That is the first root, because if over here x is equal to -2, then x plus 2 would be equal to one of the factors. The second one is x is equal to 4 over here. So you can write 4 minus x as the second root. Now when you multiply these two roots, I multiply 2 with 8, I get 8, or 2 with 4, I get 8. Then I multiply 2 with -x, I get -2x. Then I multiply positive x with 4x, I get positive 4x. And then I multiply positive x with -x, I get -x squared. If I compress this, if I simplify this, I get 8 plus 2x minus x squared. This is the equation of this graph that we have. Now, since we already have the value of P, we plug it in to find the value of Q. Q in this case is supposed to be the value of y. So this function Q, this function is of Q. So the function of Q, the function of P, sorry. The function of P, one second, function of P is this equation, 8 plus 2p, instead of x I can write p over here, because I'm trying to substitute the value of x with the value of p, because they both are the same in this graph. So 8 plus 2p minus p squared. Now this part is actually q, so you do 8 plus 2, and now you can substitute the value of p, which is 1, into this equation. So I do 1 over here and I plug 1 over here. So I get q is equal to 8 plus 2 minus 1, which is 8 plus 2 minus 1. Q comes out to be 9. So the value is 9. Hope you learned something. The complete working of this question is present in the description below for you to download. If you like the video, hit the subscribe button, and thank you so much for watching.